Hello! This video is about pH, what it means, and how to measure it. The pH scale runs from 0 to 14, and it tells us about acids and bases. pH 7 is neutral. pH values less than 7, from 0 to 6, are acidic. pH values higher than 7, from 8 to 14, are alkaline or basic. Here are some substances you may have in your house. Pure water is neutral. It has a pH of 7. pH values less than 7 are acidic, but this is not a binary, this is a spectrum. So pH values that are close to 7, like 5 or 6, are weak acids. pH values that are very low, like 0 or 1, are strong acids. The lower the pH value, the stronger the acid. The same thing is true on the base side of the spectrum. pH values that are close to 7, like 8 or 9, are weak bases. pH values that are very high, like 13 or 14, are strong bases. The higher the pH value, the stronger the base. In both sides, the closer the pH is to 7, the weaker the acid or the base. pH values far from 7 are strong acids or bases. But what does pH actually measure? Where do these numbers come from? These numbers are related to the concentration of hydrogen ions in an aqueous solution. The H in pH stands for hydrogen. The lower the pH, the stronger the acid, the higher the concentration of H+ hydrogen ions. The higher the pH, the more basic something is, the lower the concentration of hydrogen ions, and the stronger the concentration of hydroxide ions, OH-. So low pH values have a high concentration of hydrogen ions. High pH values have a low concentration of hydrogen ions. It's a little bit confusing because it may be backwards from what you expect. Here are some numbers. These pH values didn't just come from nowhere. There's an equation. The equation is at the bottom of the screen. The pH is equal to the negative logarithm of H+. We don't need to worry about exactly what that means, but let's look at the yellow bar to see what we do need to know. As the pH goes from 0 to 1 to 2 to 3, the concentration of hydrogen ions changes by a factor of 10. It goes from 10 to the minus 1 to 10 to the minus 2 to 10 to the minus 3 to 10 to the minus 4, so each step is changing by a factor of 10. pH is logarithmic. This means that each change of one pH value changes the concentration of hydrogen ions by 10 times. Let's see what this means. If we compare three solutions, pH 5, pH 4, and pH 3, they are all acidic because they all have pHs that are less than 7. But they are not equally acidic. pH 5 is a pretty high pH value for an acid. It's close to 7. So the pH 5 is less acidic. It is a relatively weak acid. But the lower the pH value, the stronger the acid. So pH 4 is more acidic than pH 5, and pH 3 is even more acidic than pH 5. More than that, we can compare the concentration of hydrogen ions in these three solutions. Using pH 5 as a benchmark, pH 4 is one step on the pH scale, from 5 to 4. That one step means that the concentration of hydrogen ions is 10 times as much in pH 4 as pH 5. pH 3 is 2 steps on the pH scale, 5 to 4 to 3. So that means that the concentration of hydrogen ions will be 10 times and 10 times again, so that's 100 times the concentration of H+ in pH 3 compared to pH 5. Last thing we need to know about pH is that we can measure or detect pH using indicators. We've seen litmus paper already. Blue litmus paper turns red in an acid. Red litmus paper turns blue in a base. There's also a substance called universal indicator. That's what this color scale that we saw at the beginning of the video represents. Universal indicator is an indicator that changes colors and is different colors at different pH values. Red cabbage juice, that we've also seen before, Red cabbage juice is also a pH indicator. It changes color depending on the pH. There are many pH indicators, and this chart shows you many of the examples and the color changes that happen at different pH values. The details of this are not important, but you should know that there are many different pH indicators that all change color to tell you whether the pH is higher than something or lower than something. Here's how we can use this. If we put a few drops of universal indicator in a solution of different pH values, the color of the universal indicator will tell you approximately what the pH value is. So the green solution has a pH of 7. When the universal indicator is red, that means the pH is close to 0, 0 or 1. When the universal indicator is purple, that tells you that the pH is very high, about 13 or 14. So you can match the color of the universal indicator in solution to the pH scale, and the color will tell you the pH value. That's what we need to know about pH of acids and bases. Thanks for watching.